is it? Oh, okay. All right. So this is a bit of a summary of what we're going to talk about today. We're going to explain to you why we chose recycling in AI, our methodology behind it, and the demo, of course. And finally, we're going to end up with a conclusion. All right. So today, around 200 billion tons of waste are discarded globally, and only 10% of that is recycled properly. So as you can see here, sorry. Yeah, so as you can see here, this is currently a recycling facility, and they are manually sorting the waste, and this can be prone to human error, which is why we decided to incorporate AI to make it more efficient and to lower the cost as well and lower contamination of these wastes. And yeah, next one. All right. So yeah, this is our vision. As you can see here, this is the AI-based learning model that we created, which is the brain. Then we have our eyes, which is the camera or the webcam that we are going to use today. And finally, hopefully in the future, we're able to incorporate this in robotics. And yeah. All right. So yeah, this is basically a robot that is sorting waste, which is pretty cool. So this is what we hope our model can one day achieve. All right. Yeah, so I'm going to pass it on to Anton.
Thank you, Miki. Okay, I'm going to try to quickly explain how this works. So basically, we also use YOLO, which is from Ultralytics. It's a model trained on plenty of images, and well, it's big data on images. And we chose it YOLO V9 to be specific. This is a representation of actually a YOLO V2 in a visual representation where you can see how it's what's doing behind the scenes. It's a picture is a mixture of red, green, and blue, and it sort of splits it into the different colors. And it has multiple layers where it calculates the impact of each feature and tries to find the patterns, and it's how it's working behind the scenes in a simplified way. So this is our architecture or the flow, how we managed to train our model. We chose the pre-trained YOLO V9, the small version. And basically, we found a data set online in the website RoboFlow. It is over 7,000 images actually. Like it's already labeled, so we didn't have to do that ourselves. Somebody put the effort to put it online, which we took it to train a custom YOLO V9 model from there. That means our model is already customized for garbage detection and not just general detection of images. From there on, we continue on fine-tuning the model with our setup, where we're going to use the machine to actually split the garbage into plastic or cardboard or what it's needed to split. So we had to take pictures ourselves of the back of the setup with the trash, and we had to actually label it ourselves. So this is the data we put into the fine tune to be able to have a final product working. All of this is now on the cloud. Also, we rented hardware from Google. It's on their servers now. It's because we have access to a GPU and it's faster there. So the whole idea is that the model is then from there loaded from a website, accesses through a website. So we are able to live detect each category of the garbage. So yeah, this is the data set I was telling you about. So it's basically different categories: plastic, cardboard, paper, plastic, metal, and this is we had to do this manual work of labeling. This is you can see an example here of labeling. You have to like draw the squares. This is metal. This is plastic. This is also plastic. This is cardboard. So we did it with a couple, with over 100 photos. It took us some time. So there's a lot of manual work behind the scenes to have a data set prepared. And then at the end, so because we wanted to have a larger data set, there's data augmentation, which is a process of like simulating another image from the original image. So the model is able to generalize more. This is, yeah, they can see the example here. We shear it, we rotate it, we blur it. So the model is able to, so if we have more data at the end, we are able to increase our own data without much effort. So then what we do is, so we split the data set into what is coming for the training and for the test. So the model improves itself based on the score. And so now, yeah, we can test it. Just give it us minutes. So we prepare it. Okay. You want here? Okay.
Oh,
Okay, just use your imagination, please. This is the most we could get. Thank you.
Oh, is it not shared? Oh, yeah, yeah. Oh, sorry. Oh, you can, oh. Yeah, so in the meantime, I'll just explain this whole setup. This is basically, we're trying to simulate a recycling facility. And this is like a conveyor belt that we created, all thanks to our mechanical engineer, Anton. And yeah, so now we're just putting our trash that we've collected over this week. And yeah, so our model is hopefully going to be able to accurately predict each one. So yeah. So here we have our webcam set up right here on the top. And now we're just going to show you. Yeah, sounds good.
All good?
All good, all good. Yeah. So yeah, as you can see here, this is paper. Our model is classifying it correctly as paper. Now he's just gonna, roll the conveyor belt. And yeah, so that one isn't that great. Of course, it's supposed to be metal, but you see that it's, yeah. So here on top, we have cardboard, which is correct. And then metal, and on the side, you can see just the number. It just means the confidence level, how sure it is of the waste that it's predicting. So here we have metal, an 84% confidence rate. Yeah, there you go. And then, yeah, plastic, metal. So it's so far accurately, for the most part, predicting correctly. Now it's getting stuck. All right, that is our model. Oh, we have some, wait, we have just like final remarks. All right, yeah. So yeah, of course, as you saw, it didn't completely accurately predict each one. And that's because our data set was only around 7,000 images. So what we hope to do in the future is increase the number of images we get, or we were able to accurately predict our model with a larger data set. And then maybe even specify those waste products according to country, because of course in different countries there are different products. Yeah, and then also maybe turn it into an app so people can just use it in their everyday lives to, classify waste and put it into the specific bins. So yeah. And finally, we want to thank our teachers that helped us during this hard 2 weeks, Nikita and Karim. Yeah, they've been extremely helpful, and we wouldn't